Hello everyone, today we will do the first tutorial. We will model an airflow in a pipe with a 90-degree bend. The inlet velocity is 2 meters per second and the diameter of the pipe is 600 millimeters. First, let's begin with the points, and with the help of these points we will create a center line. Let's start with the first point, which will just be the default coordinates, so just click create point. The next will be at 3 meters on the X. Now we need points for the arc. One will be at 3.0 for the X and 0.6 for the Y, for the center of the arc, as you can see here. Next, we will need a point at 3.6 for the X and 0.6 for the Y. Finally, we need the last point for the end of the pipe at 3.6x and then 6.6 at the Y. Now select the line tool. With the line tool selected, left-click to generate a line horizontally, vertically, and then switch to the arc tool. Following the hint in the bottom left, you can click the center of the arc, the second point of the radius, and then the third point of the radius, and then you get a curve. The next step will be a pull function. However, before we can do that, we need to create a circular surface. So we already have the center point on the left, as you can see here. Now let's complete two more points on the diameter in order to make a circle. One for 0.3 in the y direction and one for 0.3 in the z direction. Create the circle using the center point and the 2 points on the radius. Now that we have the circle, we can press the Create Edge Surface button and create a surface. Now click on the Pull tool, click on the surface, click on the horizontal line. After that, you can press on the following surface, then press the curve, then press the end of that, and then the vertical line. Now you have a pipe. Now for visibility purposes, you can hide the eSurface1 and Circle1. Next, we need to combine the three bodies because the program only supports one body. We will use the boolean operation add, the green plus sign, on the left side of the screen in geometry operations to merge them. Now select the horizontal part of the pipe and the bend. Now do the same for the horizontal portion and the vertical portion, and now you have a single body. Now we can move on to the naming of the inlet and the outlet. Right-click the entrance and call it inlet, and then right-click the exit and call it outlet. By default, all other surfaces will be named wall. Next, press to mesh. For the mesh, we will use the default cell size and refinement. We select yes in the wall treatment dropdown to generate prism layers near the wall. You may now press generate. Now that the mesh is generated, you can view the model. You translate the view using the right mouse button on your mouse, scroll to zoom, and pressing down the middle mouse button allows to rotate the model. We can check the prism layers near the wall by zooming in and cutting the mesh with a cut plane on the right side. Visual artifacts here are entirely visual and do not affect the calculation of the simulation. The number of the cells is around 155,000. Checking the mesh quality, it is above the green line, so it is a good mesh. Next, press to set up. We will keep the steady flow for the simulation, though transient will be added in the future if needed. The model will be the standard SST model with no heat transfer. Since the velocity is low, the flow is incompressible. We're using air as our fluid, just leave that as default. Now let's set up the inlet. Set the velocity to 2 meters per second, change the length scale to the pipe diameter of 600 millimeters, and keep the default 5% turbulent intensity. Notice the color change confirming the selection. Next, let's do the outlet. Press on it on the left side, keep all the settings the same, including the pressure, click apply, and then you can see on the top, it will change to blue. And now if you want to check the gauge pressure, go to settings, operating conditions, and currently the reference pressure is 101 kilopascals. Next we can move to the final piece, the wall. Just leave everything as default and click apply. Now that the setup tab is complete, we can click to solution. Before running, we will create a monitoring point close to the exit at x equals 3.6 and y equals 6.0. Now it appears in monitoring entities. Left click, change the variable to velocity, and press apply. Next we will monitor the outlet and choose the same velocity as the previous. Next, press run. After a few minutes, your simulation should be done. Once the solution converges and results stabilize, we can move on to post-processing by pressing to result. In the results tab, we have three post entities, a point, a line, and a plane. Let's start with a point. We will set it to 3.6x, 6.0y. You'll then see it in the graphical window as a dot near the top of the pipe. Now we can press the point in post entities and select the variable to velocity, which we can see here. The average, max, and min are disabled for our point. Pressing on post entities again allows us to see the velocity. In the velocity, it gives us the velocity vector with three components, unlike the other one, which was just velocity magnitude with one value. Next, we can do a line. For the line, let's choose the point 2.9 at x, 6.0 for y, and 4.3 for x, and 6.0 for y, which can now be seen on screen. We can now select the line in post entities like we did with the point, and see the velocity profile for average, maximum, and minimum. Closing that window, we can do the last post entity, the plane. We can create it with default settings, which will make a plane in the XY direction, as you can see here. You can click on the generated plane in post entities and select velocity and press apply. Now hiding previous work and hiding the pipe geometry on the right, while leaving the contour gives us a good look at the flow inside the pipe without any distractions. Finally, hide the contour and click Wall in Post Entities, and in the variable drop-down choose Absolute Pressure, and for report type choose Pressure Force. Mass flow is not applicable to wall, thus it is grayed out, but it is applicable to inlet and outlet if needed. You may now click Close and show to see the pressure on the wall. The last step is to generate an automatic report. This provides all the information about the geometry, mesh, setup, and solution, including graphs, contour plots, and pressure data. That's all for the tutorial. Thank you for watching and happy simulating.